Welcome back to 6.2, solving using substitution. This is solving systems of equations specifically by substitution. We already learned about in the previous videos how to do it by graphing. Now we're going to do it algebraically by substitution. And the substitution method is the replacing of a variable with its equal value. So there's a lot of instances when we can use substitution, and we're going to show how that directly applies to systems of equations, okay? So there's this three-step process, and step one is isolate the x or y, that means get it by itself, in one of the equations. So you can pick which one to isolate either x or y. So there's a couple things going on here. Number one is you need to figure out which equation has an x or y variable that's easy to get by itself. And number two, you need to decide which x or y to get by itself is easiest. Okay, so there's a lot of strategy that you'll learn the nuance of as you go along. So step two, after we've isolated x or y, that means we get x equals something or y equals something. What we're going to do is we're going to plug the value of the variable into the other equation and solve in terms of other variable. I know there's a lot of other, and it might be confusing which variables we're talking about it, but I wanted to keep it more general just so you can understand that these are the basic principles you have to follow. And then once you understand these steps, you can apply it to any situation. So step three, plug in known value of variable back into either equation. This is the only time that you can choose either equation. And of course, we're going to be solving for the remaining variable. Okay, so step one, isolate x or y. Step two, plug that into the other equation. Step three, plug the known value, and I really want to emphasize known value here. Okay, once you have, and that means x equals a number or y equals a number. Okay, no variables. Once we have a known value, that means it's going to be an integer, a decimal, a fraction, something, but it's not going to have a variable in it, okay? And once we have that, we're almost done. So let's go ahead and apply these principles into example one. So we have, what is the solution of, and the reason why we know it's a system of equations is because we have two equations. A system is two or more, so this is two, and that makes it a system. The first one is in slope-intercept form, y equals 3x. The second one is not. It is x plus y equals negative 32. So what we're going to do is first we're going to see, can we finish step one? Isolate x or y in one of the equations. Now, looking at equation 2, you'll notice that we have to do some work to get x or y by itself. X is not by itself. Y is not by itself. So we'd have to do some work, and that's fine. That's not hard to do, and in many cases you'll have to do that. However, if you look at the first equation, you'll notice that y is already by itself. Let me use orange. Y is already by itself, so it would make a lot more strategic sense to use the first equation, and that will be our step one. Okay, so step one, we solve. It's already solved, so we got that done. Check. Let's use green. Green means go, and we're go for number one. Number two, we're going to plug the value of the variable into the other equation and solve in terms of other variable. What do I mean by that? I like to box these values. So if I know y is by itself, I'm going to box the value on the other side of the equal sign. What does this mean? This means 3x and y are the same thing. They have the same value. That's why there's an equal sign there, okay? So if they have the same value, then this value, 3x, can replace y, in any other expression, especially if we're looking for the solution to a system. That means where both equations are satisfied by the same values, okay? So what I'm going to do is I'm going to take this and I'm going to plug it into y for the other equation because I already said they're equivalent. So let me show you what that looks like. We have x plus, and now instead of writing y, I'm going to show you my box. Okay, my green box here. And I put in 3x. Y is the same thing as 3x, so I can replace y with 3x equals negative 32. Okay, so now it's basically another equation, but how many variables do you see? We see two variables, but they're both the same. That's very important. We only want to solve equations when there's one variable. If we have two variables, what do? There's two unknowns. Okay, so if we have one equation with only one unknown, x, even though there's two of them right now, we're going to be able to combine later, but if we have an equation with only one variable, we can solve for it. So that's going to be our goal. Let's proceed to the next step. So I have x plus 3x equals negative 32. This is an equivalent equation. So now I'm going to combine like terms. 4x equals negative 32. I divide by 4, and I get x equals negative 8. Now, we are ready. We just finished step 2, and we are ready for step 3. Notice how I have x equals a number. I had x equals negative 8. Before, I had y equals 3x. That's not the same thing as having a known value, okay? So once you have x equals a number or y equals a number, you're almost done. Now, what can we do with this? Well, once we have, let me use pink. Once I have x equals negative 8, I can plug this into x into either equation. And we're talking about up here. Now, why would I not want to plug it in here? Well, the whole goal is to find y. And if I plug it into something that doesn't have y, what's the point? Okay, so I'm going to plug it into 1 or 2. I said that backwards. 2 or 1, okay? And to me, it's going to look like it's going to be easy to solve for number 1. Again, this is some strategy, and the more you do it, the more you'll know which one's the better choice. So I'm going to go ahead and solve for number 1 once I plug in the value of x. Would you be wrong by plugging into 2? No, you would not be wrong, but you might spend a little bit more time. It's all kind of your preference, and once you do this enough, you'll have some experience and know which ones are good ways to do it, which ones might take a little bit longer. But you wouldn't be wrong plugging it into either 1 or 2, okay? So I plugged in the value. Instead of writing x, I wrote negative 8 because we found the known value of x. So now I'm just going to multiply. 3 times negative 8 is negative 24. Now, what does this mean? Let's put it into the context of the problem. The solution to a system is where the values of x and y satisfy both equations, okay? So it is a location. It is the intersection of two lines. So this is our solution, okay? So that is example 1. We're going to go ahead and cruise right on to example 2, so please stay with me. This one's a little bit more difficult, but we're going to see that it's not that much more complicated. So example 2, what is the solution of y equals 2x minus 3? And the other equation is 2x plus 2y equals 12, okay? Now, I already drew a hint here. The hint is clearly showing substitution, so we're going to replace y with the value of y. So you see here I drew a green box around it, and I know that's going to replace y. So let me go ahead and rewrite the equation. And I'm going to go ahead and use a purple box just to show you that's the same thing. Okay, and I'm going to put parentheses around it. If there's multiple terms, it helps to be organized, so we're going to put some parentheses around it. And actually, let me make this red for you so you see what this is coming from. So style, red. Okay, do you see what we did here? All we did is we replaced this y because y was by itself. Step 1, y was by itself already, so we're good to go to step 2. Step 2 is to plug in the value of y into the other equation. It has to be into the other equation, okay? So we moved on to step 2. We plugged it into the other equation. Instead of writing y, we wrote the value that y is equal to. And now we only have the equation in terms of x. So we're ready to proceed. Now we're going to go ahead and use all purple. Okay, this just means we're going to be multiplying 2 times that whole quantity inside. So let's go ahead and do that. So I'm going to multiply this 2, distribute. So we have 2x plus 4x minus 2 times 3, 6 equals 12. Combine like terms. Always do that first. 6x minus 6 equals 12. The x is not alone. In order to get it alone, I need to do the opposite operation. So I add 6 to both sides to undo the negative 6. I do 12 plus 6 is definitely not 6. Not sure why I wrote that. It is definitely 18. And then I divide by 6 and I get x equals 3. I have a known value. Now I can plug this into either equation. Hopefully you guys can use some strategy, some common sense, and realize it looks like the first equation is going to be a little bit easier to solve for y. Okay, you're going to have a few fewer steps involved. So I'm going to go ahead and write y equals 2x minus 3, but instead of writing x, I'm going to write our known value, which is 3. So let's proceed from here. Y equals 2 times 3 is 6 minus 3. Y equals 3. What does this all mean? This is our point of intersection. These are the x and y values that are true for both equations. It's where they intersect if you graph these on the coordinate plane. And voila. Hope you found this helpful. Let me know if you have any questions, and I will see you next time.